Hello, Algebra 2 scholars. This is Mr. Benzel here, and I'm looking forward to working with you this summer. So we're going to be taking our first video notes. So if you could have a pen and paper, or pull up a Google Doc as well, and feel free to pause the video or take screenshots of some of the examples. I do want you to create a document or take a picture of your notes and submit them to our Google Classroom. So the essential question, probability. Probability was, around for a while. But the story goes that one of the mathematicians who worked on probability actually spent his time discovering a theories of probability, flipping a coin in a jail cell. And the essential question is, how likely is it that I will get a head if I flip my coin? And one question that we might ask is, if I flip a coin 10 times, am I going to get 5 heads in the 10 coin flips? So I can actually just take this quarter, for instance, and flip it 10 times. So let's say, just to save you a little time, let's say that I got head, 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 tail, tail, head, head, tail, head, tail. So I had 6 heads and 4 tails. Now we might think that, and commonsensically, that we get 5 heads and 5 tails, since it's a 50% chance in theory, but with this experimental probability, the experimental probability here was actually 60%. So let's look at a few basic terms here. So what we can say is that the short-term frequency is more unpredictable. So in that coin flip example, maybe I have 7 heads and 3 tails, or maybe it's 3 tails and 3 heads and 7 tails, something like that. And then the long-term frequency is more predictable, and it is more likely to be in lines of what our common sense is. So our theoretical probability is what we would expect to happen. And then the experimental is what actually happens. So the probability that event A occurs is simply the number of times event A occurs over the total number of trials. Total. And then the complement of event A is the probability that it's not A. This is 1 minus the probability of A. So if I had a 40% chance of rain, there'd be a 60% chance that it would not rain, for instance. And then for now, the probability of A or B would just be the probability of A plus the probability of B for now. We'll talk about situations where that might change a little bit. And then the probability of at least 1 is doing 1 minus the probability of getting a 0. So when we do probability models, the first thing that we need to do is list all the possible outcomes, knowing that all probabilities are between 0 and 1. And that all probabilities do, in fact, add to 1. So let's take a look here at an example. So this is an online role-playing game where players can create detailed designs for their characters' costumes or appearances. Aaron sets up a website where players can buy and sell these costumes online. Based off of these results, express the probability that the next person will purchase no costume as a decimal to the nearest hundredth. So we are looking at no costume. And we might ask ourselves, what that probability is going to be. So we will let A equal no costume. So the probability of no costume equals to number of times A occurs over total. And let's say that I want to know what the total is. I'm just going to add these up, all three numbers. So I'm going to do 38 plus 239 plus 12, 289. So when I'm doing that, number of times A occurs is 38 divided by 289. And they want to the nearest hundredth. So I'm just going to go to my calculator and I'm going to do 38 divided by 289. And that's going to be about 0.13. So hundredth just means 2 decimal places. All right, example 2. This is the School of Rock. And it's asking us for the probability that a 7th grader chosen at random will play an instrument other than bass. So this is 1 minus the probability of bass. And it might be helpful to think about how many 7th graders we have in total. So if I add the 10, the 4, and the 2 14s, I get 42. So, and it's asking us for the percent to the nearest whole number. So when I'm doing that, I would write 1 as 42 over 42 minus 4 over 42. You could also just simply add up the 10 and the 2 14s to get 38 as well and get the same thing. So just as long as you're kind of showing me like what you entered in your calculator. So when we do 38 divided by 42, we get about 0.904. Which is approximately 90%. All right, and then example 3, this is kind of a data table here with Skittles. So the first question is, what is the probability of 0.214 for purple meaning in this setting? So this means that this is a distribution of Skittles that comes in a fun-sized bag. So we can interpret this that theoretically, we have a 21.4% chance of drawing a Skittle. And the question is, what is the probability that we are going to get red? So to do that, you're going to do 1 minus 0.171 minus 0.214 minus 0.204. So we're working backwards from 1 minus 0.214. And we're going to find out in our calculator what that's going to be. And we're going to get 0.197. Actually, I should take out for this first one here. It's not quite like theoretical. It's close to being theoretical. But in our very large sample, so kind of scratch what we said here for number one, but rather we could just say in our very large sample, 21.4% of the Skittles were red. All right, and then the next question is, what is the probability that a randomly selected Skittle is green or purple? So this is simply the idea that we're going to do the probability of green plus the probability of purple. Purple, here we go. And we're just going to add 0.171 plus 0.214. And we're going to see what that equals to. And that's going to equal to 0.385. And then the last question is, what is the probability that it's not yellow? So I'm just going to do 1 minus the probability of yellow. So if I just do, for that, if I just do 1 minus 0.214, I will get 0.786. And that is our final answer for that. So make sure you have all your notes in order. And if you are done with your notes early, you may start your Delta Math assignment for skill 1.1, but we will, at the end of the video watching time, have a skill 1.1 peer deck check-in. Thank you very much.